For today's lesson, we are going to be going over the Pythagorean Theorem. I know last class we spoke about it briefly and Pythagoras and the formula and things like that. Right now, I'm just going to write down. Make sure you guys are taking notes. We're going to speak on the Pythagorean Theorem, and we're going to speak on the formula, and I'm going to show you guys a concrete model that'll hopefully get you guys to understand everything a little bit better. So we know that the formula is a squared plus b squared equals c squared, right? So we know this is the formula. Let me make it nice and pretty for you guys. So I'm going to show you guys, well, first we're going to go over a real life example. And that example is going to be based off of a road trip. So let's say you guys are going out of town and you guys are deciding on which two ways to take, right? So just like a triangle, let's see, we're going to start at this destination right here. And this is the destination we got to go to, right? So we can take this route. Or we can go this way. And this is our other angle. So we can either go this route or go this way. GPS is telling us these are the only two options. And really, we want to see what's the shortest distance. So, I mean, we could get there the fastest, right? So we know that this is going to be A, because it's one length. This is going to be B, because it's the second length. And this is going to be C. So we know that getting to this destination, it's just going to be straight one length. It's going to be C. And getting to this destination from this route, it's going to be A plus B. So we know that the destination is either A plus B or just C. Right? I'm going to show you a concrete model now on how to get the answer for C given A and B. So we have this triangle here that you guys probably cannot see, so I'm going to outline it. And this triangle is going to represent our distance, right? And just for time purposes, I'm going to use low numbers, that way we don't get confused. We're going to label this angle right here 3. We're going to label this angle, the length, right? We're going to make this one 4. And then we're going to make this one 5. And I'm going to show you why we sort of already know this. So given this, we have this grid, this 3x3 grid, this square, that's 3x3 lengthwise. And then we have this square that's 4x4 lengthwise. And then we have this square that's 5x5 lengthwise. Or, yeah. So we know that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's in this grid, in this 4x4 grid, there's 16 smaller squares. And in this 3x3 grid, there is 9 small squares. So we can say that 4x4 equals 16. And we can say that 3 by 3 equals 9, right? So if we take a squared plus b squared, that should equal c squared, correct? So 4 squared plus 3 squared, equals c squared. So, right, we already said that 4 times 4 is 16 plus, 3 times 3 is 9, and that equals c squared, right? So this is 25. 25 equals c squared. Now, I know I gave you guys the length here, but I'm going to show you how we know that c is 20, or well, c is 5 and yc squared is 25. So we have a 5 by 5 we have a 5 by 5 square here, and we're going to go ahead and label each grid, or each square in this grid. Say 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Boom, shakalaka, there you have it. So when we do the math, and I'll show you guys again, 25 equals c squared. Now when you square root it to get c by itself, you get 5 equals c, which is what we have here, 5 for the hypotenuse. And now, when we, square it without the grid, it's basically going to give us, we're going to get this and this, and 25, right? Without the grid. If we were to use it and we were to just use the formula, I'm showing you now with a square and given the grid size. And this can be mocked up into a larger scale. This can also be used in inches, and it can be miles, however you want to use it. This is just a model that I was showing you guys, so you guys can sort of understand and get what I'm trying to get at with this model. Lastly, we will focus on using this in everyday life. I know you guys are big on saying, oh, when am I going to use this? I'll never use this again, this and that. Let's just say that your family, or no, you are, you're painting a house, right? So we know that the house, this is the wall of the house. We'll label it, right? This is the wall. This is the ground. And over here, well, I'll leave it over here because we haven't found out the information yet. But over here we have the ladder. We want to lean this ladder against the house, and we want to find a secure length on the ground of how far the legs should be from the wall of the house. So let's say we have a 6-foot ladder, right? And we have a, let's say, 4-foot wall. We want to see on the ground, and I know this is a small wall. I'm using small numbers again. Try not to confuse anybody. Excuse me. So we want to find out what will be the appropriate length on the ground where the legs should go, right? So given C, because 6 is going to be C because it's going to be leaning, and given A or B, whichever you choose to call it, we'll just call it A for now. Given C and A, we're going to plug that into our equation. So it's going to be A squared plus B squared equals C squared, right? A is going to be 4. We do not know B. And C is going to be 6. Now, I know a lot of you are stumped and you guys might be questioning yourselves. We are going to have to flip this problem around. I know We don't have B, so you guys probably are, you know, a little confused right now, but the same way we can add, if you move the equation around, we can also subtract. So we are going to do 6 squared minus 4 squared equals B squared, okay? Excuse me. So 6 times 6 is 36 minus 16 squared, excuse me, equals B squared. So yeah, 6 times 6, 36, 4 times 4 is 16. So when you subtract the 2, you get 20, and 20 is going to be B squared, okay? When we do that, we're going to now solve for the square root. Excuse me, I'm going to move this up a little bit. So 20 square rooted equals B squared. The square root and the squared are going to cancel out, which is going to leave you B. And 20 squared is, let's do a, so 20, 2 times 10, right? Then we have 2 times 5. So it's 2 square root 5. And when we plug that into the calculator, which I am going to do right now, that is going to give us 4.47. And I would like you guys to stop at the hundreds place, because it goes on to 213. Just stop at the hundreds point, and that'll, I know it won't give you the exact, you know, measurement when you plug this back into the equation, but that's where I would prefer you guys to stop at. So B equals 4.47. So now we know that the ladder should be 4.47. We'll make these feet, and then the ladder was 6 feet. So it should be 4.47 feet away from the wall. The legs of the ladder should be 4.47 feet away from the wall. Well, that concludes our lesson today. I appreciate you guys paying attention, and hopefully this concept stays in your head, and if not, feel free to ask me questions.